Before solving the problem, first let us look into the rules to solve this problem. If the blocks are in series, then it must be multiplied. If the blocks are in parallel in same direction, then it must be added. If the blocks are with a negative feedback loop, then we must use this formula, which is gain block divided by 1 plus or minus gain block into the feedback block. Here the gain block is g of s and the feedback block is h1. For a negative feedback block, it is plus here. For a positive feedback block, it is minus here. Now let us look into the problem. As you can see in this problem, there are 3 gain blocks and 3 feedback blocks. Here, as you can see, G3 block is connected to both H2 and H1, and G2 block is only connected to H1, and G1 block is connected to all the 3 blocks H3, H2, H1. As I've rewritten this again, now as you can see, G3, H2, H1 are with a negative feedback. H2, H1 are in series and they get multiplied here, and as I've told you, you can use this formula. Here g of s is g3 just divided by 1 plus g3 h2 h1. As g2 is in series with this block, it becomes g2 g3 divided by 1 plus g3 h2 h1. Again you have to write this in block diagram as I've written here. This must be added in the block diagram and rewritten. Now the reduced block diagram is this, with G2, G3 gets multiplied and which is with the negative feedback to H1. Again you can use this formula. Here G of S 1 plus because of negative feedback, G of S into H of S. Here H of S is H1. By using the LCM method, we can solve this and again add this block in the block diagram and rewrite it, and it becomes multiplied with G1 with a negative feedback loop. You can see here I've rewritten the block here. Again this becomes a negative feedback to this H3, H2, H1 block. Again by using this formula you can solve this. This is G of S and this is H of S. G of S 1 plus because of negative feedback, G of S into H of S, and by using this LCM method you can solve this. The final answer is the transfer function of the entire block diagram.